Lesson 9, Inverse Functions. Inverse functions are functions that switch the x and y. So they switch the inputs and the outputs of a function. So they do the exact opposite. If you'd like, inverses are functions that undo each other. You verify two functions are inverses by showing that the compositions produce x. So f composed with g gives you x, g composed with f gives you x. So if you compose them, you should get x. So let's verify that these are inverses. So let's go the f composed with g route, I suppose. So I'm going to take function g, I'm going to plug it into function f. So it was 7x minus 4, but the x was replaced with function g. And now I have to simplify. We're multiplying by 7 and dividing by 7, so they cancel out. Add 4, subtract 4, they cancel out, and we're left with x, which means we have shown this, and thus they are inverses. I believe that if one composition gives you x, the other one will also, so you only have to show either f composed with g or g composed with f. Talking about the graphs of inverses, they're reflected over the line y equals x. It's the dotted line in this graph here. So if you take a point 2, 1, and the inverse switches the x and the y, so instead of 2, 1, it'd be 1, 2. Notice those are the same distance from the dotted line, diagonal line there, the y equals x. So it happens if I take the graph of our function, the dark one on the bottom, its inverse is reflected over this line. It's flipped over that way to the other side. So everything goes the same distance to the other side of that line. A function is 1 to 1 if each y corresponds to exactly 1x. So these functions are 1 to 1. They pass the horizontal line test. So any horizontal line only touches each function once. If it's a 1 to 1 function, the inverse will also be a 1 to 1 function. So again, 1 to 1 means that a function is each x goes to 1y. To be 1 to 1, each y only goes to 1x. So each x and each y is only there once in the function. So how do you find inverses? Well, if it's written as f of x in function notation, I replace that with y. Then you switch the x and the y, because that's what an inverse does, and you solve for y. And if it was originally written in functional notation, you end by writing it in functional notation by replacing the y with the inverse. This little -1 on the function name stands for inverse. So it's the inverse f of x. So let's find the inverse of this function. So we start by replacing the f of x with a y. Switch the x and the y's, which means y's become x's and x's become y's. If there's more than one x, all of them would become y's. Then we solve for y, so I'll cube both sides and subtract 10. And then let's rewrite it as in functional notation. So it's inverse f of x equals x cubed minus 10. Let's try another one. All right, find the inverse of this. So I'm going to switch the x and the y. Or sorry, write the f of x as y first. Then I'll switch the x and the y, so all the y's become x's, all the x's become y's. I know this x is less than 0, which is now y is less than 0. Looks funny. Just bear with me. Solve for y. So I'll add 2. And then I'll take a square root. Remember, when you're solving and take a square root, you have to put the plus and minus. And here is where that comes into play. It says y is less than 0. So the reason why we have that is because this original function is a parabola. It is not one-to-one. Therefore, the inverse will not be a function. But in math, we like functions. So what they've done is they've taken and said just this part of our function is what we're looking at. That is one-to-one. After we reflect it, we want just that same half of it, which happens to be the part where y is less than 0. So that's the negative. So we're going to keep the negative, not the positive. Now that we've chosen the negative based on this requirement that y is less than 0, it can go away because since it's negative, y is less than 0. And that is our inverse. So you use this little bit here to decide when you get the plus and minus of whether it'll be the plus or the minus.